Hi everyone. Today in this video we are going to discuss how to evaluate the performance of machine learning model. Why is evaluating a machine learning model important? It helps determine if the model can be trusted in the real world by assessing its performance on unseen data. In this video we'll discuss how to evaluate the classification models and regression models. So first of all, we'll discuss about evaluation of classification models. The metrics for evaluation are accuracy, recall, AUC/ROC, precision, F1 score, and confusion matrix. How has the model classified the data? The model may classify the data correctly as the class of interest, or it may classify it as correctly as not the class of interest, or it may classify incorrectly as the class of interest, or incorrectly as not the class of interest. So in short, we can take it as TP, TN, FP and FN. Let us take a small example of a cricket match. For predicting whether the team will win or lose the match, the model may predict a win, but actually the team wins. Then it is called as true positive or TP. The model predicts win and the team may lose. Then it is called as false positive or FP. The model predicted loss and the team won. Then it is called as false negative. The model predicted loss and actually the team has lost, then it is called as true negative. So the correct predictions are true positive and true negatives, and the incorrect predictions are false positive or FP and FN, false negative. We can calculate the accuracy of the model by using the formula TP plus TN, that is the number of true predictions divided by total number of predictions, that is TP plus FP plus FN plus TN. Let us take this confusion matrix where the values of true positives, false negatives and true negatives are given. By using this value, we can calculate the model accuracy in this way, and here we are getting a accuracy of 94%. Similarly, we can also calculate the error rate, which is the percentage of misclassifications, by using the formula FP plus FN, that is total number of incorrect predictions divided by total number of predictions. So here in this example we are getting an error rate of 6%, which is equal to 1 minus model accuracy, or in percentage terms it is 100 minus model accuracy. Sometimes correct prediction both TPs as well as TNs may happen by mere coincidence. Since these occurrences boost model accuracy, ideally it should not happen. Kappa value of a model indicates the adjusted model accuracy. It is calculated using the formula below. And this kappa value is mainly useful when we have a class imbalance problem in the dataset. So kappa value equals to model accuracy PA, which is model accuracy, minus PPR divided by 1 minus PPR, where PPR is equal to proportion of expected agreement between actual and predicted data, both in case of class of interest as well as the other classes. So this is the formula for p-pair. By using the value of model accuracy, which is PA, and p-pair, we can get the kappa value in this way. The more the kappa value, the more is the model performance. Apart from model accuracy, we can also have some more parameters called as sensitivity and specificity. In some problems like medical healthcare, there are some measures of model performance which are more important than accuracy. Two such critical measurements are sensitivity and specificity of the model. The sensitivity of a model measures the proportion of TP examples or positive cases which were correctly classified. Here, sensitivity is equal to the total number of true positive divided by true positive plus false negative. A high value of sensitivity is more desirable than a high value of accuracy. Similarly, specificity of a model measures the proportion of negative examples which have been correctly classified. Specificity is equal to total number of true negatives divided by total number of true negatives plus false positive. A higher value of specificity will indicate a better model performance. Confusion matrix. Apart from sensitivity and specificity, we also have recall and precision which can be found from this confusion matrix. So recall equals to total number of true positives divided by total number of TP plus FN, and precision equals to total number of true positive divided by total number of TP plus FP. Receiver operating characteristic, or in short ROC curves. ROC curve helps in visualizing the performance of a classification model. It plots the true positive rate or TPR in the vertical axis against the false positive rate or FPR in the horizontal axis at various threshold settings, offering insights into how well a model separates positive and negative classes. The area under the curve or AUC quantifies this separability, with a higher AUC indicating better model performance. True positive rate is equal to TP divided by TP plus Fn. Similarly, false positive rate or FPR is equal to total number of false positive divided by total number of false positive plus true negative. And FPR is equal to 1 minus specificity, and TPR is equal to recall, also it is equal to sensitivity. A threshold is the value used to convert a model's predicted probability into a class label, that is 0 or 1. If threshold equals to 0.5, it means all probabilities greater or equal to 0.5 are classified as positive, that is 1, and others are 0, that is negative. In applications like medical diagnosis, where false negatives are dangerous, we can use ROC curves. Similarly, in spam detection, where false positives are annoying, ROC AUC helps evaluate the trade-offs between true positives and false positives over various thresholds. It avoids misleading conclusions from accuracy. It handles imbalanced classes, allows fair comparison of models, works across all decision thresholds. So, if for a perfect classifier, we'll have one ROC value of 1. How to evaluate the performance of a regression model? The performance of a regression model is evaluated by measuring how well it predicts continuous output variables. Several quantitative metrics are used to assess the quality of the predictions compared to the actual values. So we can see one example here. The predicted output is shown as circles and the actual value is shown as cross, and the difference between the predicted value and the actual value is called as the error. Different metrics for evaluating the regression models are mean squared error or MSE, root mean squared error or RMSE, mean absolute error or MAE, R squared and adjusted R squared. Mean absolute error is the average of the absolute difference between the actual output and the predicted output, which is also called as error. Here yi is the actual value and yi hat is the predicted value. Similarly, mean squared error is the mean or average of the squared errors. Root mean squared error is just the square root of mean squared error. R squared, it gives the proportion of the variance in the dependent variables that is predictable from the independent variables. R squared error is equal to 1 minus yi minus yi hat whole square. That is error square, summation of error squares divided by yi minus y bar whole square. Here y bar is the mean value. Adjusted R squared, modified version of R square that adjusts for the number of predictors in the model. It is useful when comparing models with different numbers of features. So in this video, we discussed how to evaluate the performance of a classification model and a regression model. Thanks for watching.